So welcome to this observability clinic, unlocking Kubernetes insights, diagnosing health with Dynatrace and external agents. So welcome everyone. I'm very excited to be here. We're going to spend a bit around an hour together. And my name is Henrik Rexed. I'm a cloud native advocate, and I do things related to Kubernetes and open telemetry, and also produce content on my YouTube channel called Is It Observable? So what am I going to talk about? So I'm going to talk about technical things. Take a glass of water. I'm going to cover a lot of things, in fact, a lot of different things. And when I was creating the content, I thought, yeah, let's make like a sort of class or a course or like a sharing sections about about a specific component that we released last week, and I'm referring to the Dynatrace OpenTelemetry Collector distro. Oh, I see there's a typo here in the first slide. So here we're going to start with a small introduction about the Dynatrace OpenTelemetry Collector distro. Also, one interesting things that I want to highlight today, and it's going to be almost related to the OpenTelemetry Collector, is that on the new Kubernetes application, the new experience that we shared few months ago, there is now an additional tab on every single Kubernetes objects where we can basically display metrics that are attached to that entity. So we will see how we can successfully get our metrics in those screens. So that's going to be the purpose. So that's why I'm saying it's like a sort of course. So we're going to look at the best practices, because when it comes to ingesting data, it's fairly easy to send data to an endpoint like that, to storage like Dynatrace, which is amazing storage. But there are a few best practices. So I'd like to share those best practices. If you start planning to send data, there are a few things that we have to keep in mind. And more than just ingesting things, we're going to deal with OpenTelemetry Collector. So I want to give you some insights on what are the things you should pay attention to. So here's an example of a dashboard. And by the way, that dashboard will be available in the GitHub repo for this observability clinic. So we'll share the link in a few minutes or a couple of minutes. And so you will be able to take advantage of the dashboards, and we can talk about scaling and everything's in that area. And last, I recently delivered a talk in KubeCon about comparing fluentbit 2.0, not 3, because 3 has been released last Friday. So 2.x versus the collector, and you'll see there's interesting things. And I will share some tips about when, where, and where you should use one of those agents. So then you have more insights about it. So you ask yourself, yeah, there's not much about Dynatrace. Yes, gonna be, of course, because we're gonna do things about a demo and sharing things. But again, keep in mind that it's going to be focused on those agents, because at the end, we don't necessarily need to use one agent. We have the options to use those components to send data back to Dynatrace. Okay, so if you're ready, I suggest that we start. So just to remind, recently we deliver an application monitoring for we released the new Kubernetes experience application. We did an observability clinic about that. We did an Ask Me Anything about it. And the way, so if you are in the new platform, third generations, this new Kubernetes experience requires less privileges to be able to get the right data. So at the end, you deploy the Dynatrace operator in your cluster with the Kubernetes monitoring enable and the app monitoring. So what it means is that if you have a workload that is spin up, spin up, then our operator inject the init container with our code module, and then your pod starts and it gets instrumented by one agent. So that's if you want to get the advantage of having Dynatrace injected into your applications. But again, if you do just 100% OpenTelemetry, you're not forced to use one agent. You can also send directly your OpenTelemetry traces and metrics to your Dynatrace tenant, and here the collector will be there. But if you use that new Kubernetes experience with this recommended deployment, the logs that we used to have automatically with our operator won't be there anymore, because the logs comes with the host monitoring, so the instrumentation of your nodes, where the one agent will pick up those files that are written on the nodes automatically. So the big question is, how can I have my logs in the right objects, in the namespace, in the workload, in the node, and so on and so forth? So this is going to help you. We're going to see there is few dimensions, few things that would be required, and it's going to be similar, by the way, by the metrics. You can see here a small teaser. You see additional metrics here in the screenshot. So you see that if you do the right thing with your metrics and the logs, then you will end up with the right data in the right detail screens of your Kubernetes object. All right, so what are the artistic tools that we can use to extend the insights of our Kubernetes clusters? So, as you know, observability, some people says it's three pillars. I disagree. I think there is six pillars in total. So logs, event, metrics, traces, profiling, and exceptions. And to be able to send those different signals to your backend, so Dynatrace, you have different solutions available out there. Of course, one agent is doing everything: profiling, traces, metrics, logs, events, and everything. Everything will be managed by one agent, but sometimes you don't have necessarily the options to deploy one agents because for different security reasons, it's not your environment. So that's why sometimes you have amazing agents out there that will do a great job. So for logs, you have for fluentd, and fluentbit, the OpenTree collector, because auto logs, Promtail from Grafana. And then you have the metrics. You have same thing. Prometheus is the storage, but Prometheus exporter here I'm referring to. StatsD is the format, but I would say that there is also a solution that could expose StatsD metrics. And same thing for traces, where OpenTelemetry obviously is the biggest player now. OpenCensus is deprecated, keep in mind. So if you use OpenCensus, try to move on to OpenTelemetry. And Zipkin, again, if you're doing traces, I would recommend to use OpenTelemetry instead. And of course, profiling, the great news is that we should expect to have the first implementation from the OpenTelemetry community on the profiling sides probably end of this year. So at the moment, if you want to do profiling, you need a vendor component or pprof, but there is no standard protocol, so it's more or less the vendor approach. So collecting, keep in mind, is not storing. So whatever solution you're picking up, you decide to utilize to report extra data to your observability backend. We don't care on how you do that, how you collect that. The idea is that you need a backend, and here this is where Dynatrace makes a lot of sense, because at the end we want to have the data well structured in Grail, so then we can run our own query DQL if we want. Of course, we can use apps that are available, but if you want to dig in the data, you can run DQL, create notebooks, create dashboards, create workflows. And then, of course, Davis, in top of that, will make some suggestions, detect things. So at the end, you don't need to rely necessarily on one agent. You can do things with other type of solutions. So, but if you do so, there are some golden rules behind ingesting or sending custom data to any backends. I mean, here, obviously, we're going to mainly focus on what you need for Dynatrace. But if you were using other solutions, it would be the same story. So for each signals, collecting them is great, but we need to add context. And context usually in the OpenTelemetry world, I would say it's called resource attributes. It could be also attributes. So there's different level of attributes. So you have to attach to your records or your signals, your telemetry data, the right informations, and specifically in the Kubernetes environments, because in Kubernetes there is so much metadata that help us to figure out who is producing what, from where, which technology, and so you can utilize easily. So in the Kubernetes world, it's going to be much more easier than other environments. So if it's easy, let's do it. It's going to be much faster. And then once it's indexed, then we will be able to get a. So before we get deeper on those how to do things, I want to just remind the exciting updates, which I'm very excited about. The first updates I was referring to at the beginning is the fact that our Kubernetes application has having a new additional telemetry tab. And in fact, this tab is appearing only if there are metrics attached to that object. So here we're looking at from a workload perspective, and in our case, there are additional metrics that are attached to that workload. So the tab is displayed, and you may ask yourself, how do I get the data back there? So if you attach properly the data, it means that you will be able to have this data attached to the node or the namespace or the workload or the pod or the service and so on and so forth. So I want clearly, when I'm dealing with external data, I want to enrich it. I clearly want to have that feature, take advantage of that feature because it's a great feature. So let's figure out how we can send that data back. The other amazing, I would say, news from all the Dynatrace users and observability geeks, I would say, is the fact that now Dynatrace has an open telemetry collector distro. And you may ask yourself, but what is a distro? Well, a distro is basically a version of the collector that has been pre-built by Dynatrace in this case. And basically, we select a certain number of plugins available from the OpenTelemetry Collector contrib, which is the main repository where you have most of the plugins. And those plugins will be built, verified, secured, and we provide support. So at the end, utilizing the Dynatrace Collector distro means that you will get support from Dynatrace. The plugins and how the collector is built is being approved in a security way, so you can trust the binary that comes out of this, and then we support everything. So here I'm displaying you the actual lists of plugins that we use in this distro. Of course, if you look at the OpenTelemetry contrib, there is 70 plus plugins. And honestly, first of all, that it's not recommended to use the OpenTelemetry Collector contrib version because first of all, it's not secured. We don't know, and all the code is not scanned. And the second piece is that you have a collector that has 70 plus plugins, so you will have like 100 megs and 110 megs collector, where at least at the end you only use maybe 10 or less plugins for your pipeline. So this collector has specific publics to receive logs, syslogs, file log to read logs, or OTLP protocol, be able to get metrics, and then all the required plugins to process the data. So we will look at those in details in a few minutes. And last, to send the data to the Dynatrace, OTL-HTTP is the default protocol, but we also included OTLP in case you want to send to Jaeger if you have developers who wants to look at the traces, their own traces, locally on a separate Jaeger instance. So, what are the best practices when we need to deal with external data, specifically using the OpenTelemetry Collector? So let's have a look at it. Before we go in details, we briefly mentioned it with the previous slides, but just to remind for those who doesn't have the proper knowledge about it, the collector is a binary or a component provided by the OpenTelemetry community. It's one of the major components of the OpenTelemetry project. And when you launch the collector, it will load a configuration file, and that configuration file holds your pipelines. You will decide what you are going to achieve with the data that will go through that collector. So that's why there is several sections. You have the receiver, what type of data you would receive, processors, meaning that how I'm going to modify, adjust the data on the fly, export, where I'm going to send the data to, and last you have connectors. Connector is a way of doing more advanced pipeline, but in this story we're going to not use connectors at all. So what are the best practices? So massage your data, you must. Yes, massage the data. Why? Because we talked about it. We want to enrich. If we are getting any random data from any exporters from Prometheus, then that data, I want to make sure that the data is adjusted to the right entity. So I'm going to make sure then I'm going to enrich the data properly. So I'm going to cover how to do that in details. Then the second aspect is to filter. There are some structure of data structure that is sent to Dynatrace that may not be supported. So let's drop it. Or also the collector is sitting in your environments. And if you are running on a cloud providers and you're going to send utilizing egress communications, maybe you want to fine tune and avoid this extra cost of unuseful data. So why don't we filter at the source? So filtering will also reduce basically the number of bytes that goes out of your cluster and arrives in your Dynatrace tenant. Convert, we will talk about it specifically for metrics. And last is reduce cardinality. So we're going to talk about the costs of metrics. All right, if you're ready, I suggest we start. So enriching the data, when it comes to data coming from Kubernetes, if you want to be able to index it to the right objects, so logs and metrics that we talked about it a few minutes ago, you need to have in the metadata of your as a resource attributes of your logs or of your metrics, you need to have the pod name, the namespace, the node name, the deployment name, stateful set name, depending on the objects, daemon set name, cron job name, depending on the object, of course, and then the pod UID and the cluster ID. So if you attach everything, then with those keys, then the Kubernetes app will figure out, oh, this is related to this object. So I'm gonna pull out the metrics, or I'm gonna pull out the logs to the right display. So that's one thing which is important. The second piece is there are custom Dynatrace metadata, I would say, starting from DT. You can see there is DT Kubernetes workload kind. And, in the screen, if you remember, we're going to show that on our demo. We separate with type stateful set, type daemon set, type cron jobs, type blah, blah, blah. So you need to fill in this information to say, hey, this is a stateful set, man. So please put it on the bucket of the stateful set. And the other aspect is the cluster ID. The cluster ID is basically the same naming as the Kubernetes cluster UID that you saw before. So we're going to have to fill it this, right? So what does that mean? To enrich the data, I need first to get the metadata from Kubernetes. And then once I have the metadata, you saw there is two fields that we don't necessarily have by default in Kubernetes worlds. So I will have to create those extra resource attributes. So that's the flow that we need to do. And the great thing is that there are two distinct processors that will help us to do that. The first one is, I don't know if you're aware, I hope that you're aware, there is the Kubernetes attribute processor. And that Kubernetes attribute processor will be triggered by the collector. So this collector will send an API call to the Kubernetes API and says, hey, give me the metadata, please. And of course, to be able to achieve that, it means that your collector needs to have a service account, obviously, and with a cluster role and cluster role binding, so RBAC, that has able to list and get the various objects, a node, pod, service, deployment, blah, blah, blah. All those objects will be required because at the end, if you want to have the different details, you will have to get the rights in your Kubernetes cluster. Then you may ask yourself, yeah, but how does it basically able to attach or to link a log or a metric to a given metadata in the API? Well, by default, if you don't configure anything, this Kubernetes attribute processors will basically look at the IP address of the source, which is the pod or the pod that where we have grasped the logs, for example. So we have the IP address of the pod, and we send the request to the API server and say, oh, this is your IP address. Okay, so here's the metadata related to it. So if you don't configure it, it's going to behave like this. But sometimes you may want to get some data coming from other resources. Say, oh, this is the name of the pod comes from that one, and the namespace comes from this one. So you will use what we call pod associations. So here's an example. So Kubernetes attribute processor, we precise the type of metadata that we want to extract. So all those names. You can also add the labels, the annotations if you want. And then at the bottom, you can see I'm precising the pod associations. So you may ask yourself, yeah, but if the log doesn't have Kubernetes pod name and Kubernetes namespace name in the resource attribute, like described here, what will happen? Well, by default, if he doesn't find anything, he will use the IP address of the log or of the metadata of the telemetry that we're trying to enrich. So So if you use that rule in any way, it will work fine. You will still have some attributes out of that. So that's the first processor. The second one is that we want to modify, and to modify the logs or the traces or the metrics that we're dealing with. And we're going to use a processor called transform, and transform rely on one language called the Open Telemetry Transform Language, OTTL. And OTTL is like a SQL structure where you have a functions where in a condition, and there is so many functions available. So look at the Open Telemetry Collector, search for OTTL. You'll see there's a lot. There is some documentation, to be honest. And with those functions, you can reduce cardinality. So I can drop a key, I can delete some. So the delete key means I can remove some resource attributes. So if you want to remove pretty expensive metrics, I can do that. I can extract things. So with a regex or parse JSON, I can enrich and I can convert. So there is plenty of different functions that we can do, achieve. And in our specific case, we're going to use transform processor using this OTTL. And transform processor supports metrics, trace, and logs. And the way it works is you put transform, and then you're going to put some statements, and you need to specify what are the signals that you're targeting. So you see here it's a log statements, but you can have a trace statements or you can have a metric statements, and then you precise the context. So you may ask, say, yeah, but what is the context? Well, yeah, I will answer to your questions, Peter. It's a great question, by the way. So the context is very important. If you deal with metrics, traces, and logs, if you're in the OpenTelemetry world, what I recommend for everyone that is listening here, look at the data schema. So you understand exactly the fields available in terms of in the logging schema and the metric schema and so on. And the context basically define how much details the transform processor has access to. So you can see there's a log. In the log, there's resource attributes. Resource attribute will be available in logs, metrics, traces, everywhere. But if you just say context will be resources, it means that it has only access to the resource attribute, and that's it. If you say log, it has the access to the entire log schema. If you define metric, you will have the metric definition. And if I want to change the value of a metric, I will define data points. Or if I want to, same thing for spans. So the context is very important because at the end you fine tune your processor, and at the end the behavior of that processor that will go on each single metrics or traces or logs, whatever you have built. If you are giving access to too much data, then of course the consumptions in terms of memory were different. So if you want to fine tune your collector pipeline, try to fine tune the context as well. And then you precise the list of statements. So like here's example, we're going to set the resource attribute Kubernetes namespace, pod name, and I mentioned few fields is not existing, like the workload kind. So in the demo, we'll show you what type of transform that you should apply. Next is filtering. And I mentioned people doesn't realize that with a component like the collector or fluentbit, in fact, you can remove not unnecessary data. If I have lines that are completely blank, why should I send it to Dynatrace? I mean, I'm going to send a JSON payload because at the end of OTL logs is a JSON payload, and I will consume some network bytes over the network. So basically drop those lines, doesn't make sense. Same thing if there is a log line with some weird character and I won't never be able to do any analytics of that. Does it really matter to send it to Dynatrace? No, I don't think so. So let's drop it. Let's remove the noise and only send the very useful data structure logs that I will be able to process with DQL and do a lot of great things with notebooks and workflows and so on. And the other aspects is metrics. We'll talk about in a few minutes. If you have, by default, when we have an exporter, we say, hey, check everything. But usually in an exporter produce thousands of metrics and we only use 100 of them. Yeah, and at the end, we are consuming licenses and data for nothing. So having the option say, hey, drop me this, drop me that, I'm controlling. And the other aspect is that we don't support all the signals as of now. In the future, it will change. Specifically in the metric side, we don't support histograms, as you may know, and summaries. So it means that I will, instead of generating errors, because errors will just make the collector unstable, I will basically drop those, drop the histograms because I know that they will be rejected. Drop the summary because they will be rejected, and so on. So filter will be obviously very, very important. So here's an example. The filter processor require or utilize also OTTL language. So you can see here metrics. So I'm specifying metrics, and I'm defining the scope is metric. So the entire metric structure. And here I'm saying, okay, the type metric data type histograms. If it's equal to histogram, just drop it. And the other statement is that if the name of my metric start with Kafka consumer, just drop it. So there is plenty of functions. So you will be able to control what you want to send or not send to the backend. Then very important, really, really important. I don't know if you are aware of that, but it's really, for me, I think it's really important to remind this. In the industry, there is two distinct format of metrics. There is cumulative and there is delta. Delta is everything that is used by StatsD, and cumulative is Prometheus. And there are a couple of observability backend that only supports delta, and Dynatrace is the case. We only support delta, and there's other backend that supports only cumulative. So if you're planning to use the collector to scrape Prometheus metrics, which means that they are going to be in a cumulative format, if you send it to Dynatrace, they will be rejected because we check the cumulative form, the format of the metric, and if the format is cumulative, it will be rejected. So use the conversion, and it will make your life much more easier. And to do the conversion, of course, we have a cumulative delta processor that will do that. If you have several instances of the collector, try to use only one. Because the way it will convert, it's storing the previous values to recalculate the delta. And if you have two instances of the collector, then you don't control that metric A is only coming to the collector 1. So if the metric A comes to collector 2, then the way it's going to be converted will be completely wrong. And at the end, the metric arrives in Dynatrace, so the value is completely wrong compared to the source of the metric. And then you will build SLO, you will build alerts, you will build a workflow, and then you're basically relying on something completely wrong and not converted properly. So if you do conversion, try to do it on one single instance to avoid those bad conversions. And I have a trick specifically in Kubernetes when it comes to the demo. Last piece is the cost of your signals. So just to remind for those who's not aware, so traces is a JSON blob. So of course, if you expand it, the traces will be obviously bigger because it's a big JSON file, logs as well. And then we have sampling. Logs will be received quite often, and we usually think that metrics is the less expensive, but it really depends on the how the metric is built. So and this is basically the notion of number of labels, so dimensions, and cardinality. So here as an example, so I have a Kepler container joule total, which is the metric name, and I have three labels. So this is a very basic example: Kubernetes pod name, namespace, container name. And then the cardinality is the distribution of the values within that labels. So if I have pod name, if I have a cluster, I may have, let's say 100, 600, it's not a big deal. But if I use, for example, Kepler has a process ID, and based on each container will have a process ID. So then the cardinality of the metrics produced will explode. I will have thousands of values possible for that labels. And at the end, you can see all the combinations. At the end, the metric will be stored with all the combinations of the labels. And then, so the metric itself will be, when you store it, is going to be, the cost will be exponential. So yeah, look at the metric, look at it and say, oh, but the process ID, I don't need it because I will never use it. Or this label here, this dimension, it's just a waste. So let's move it. Let's drop it. Same thing if you have metrics that you are not going to do anything about it because it doesn't make sense for you, just drop it. And then you will be more efficient. So how do you drop and control those the cost and the metric itself? Well, there is a few ways of doing it. There is the basically through Prometheus receiver in the collector that will define how, where, and what you should collect. you have relabeling configs. And relabeling configs give you the luxury. Here you have an example where here I'm going to say, oh, all the metric name here, if it's the regex I mean, this name, please drop the metric. Same thing here. Everything that starts with go underscore, drop it. And then you have functions like label drop. So here I want to drop the container ID. I want to drop the process ID. So by doing this, I'm dropping things that I don't need. And at the end, it will be less expensive to store that metrics. And also PID, I will never do anything about it, specifically in my use case. So it doesn't make sense to send something that will just explode this metric. So I will control by looking at it. So yes, you will say, yeah, but it's painful. I need to look at all the metrics that comes in. Yeah, I agree. It's kind of a bummer, but at the end, if you want to avoid sending bad things, then you will control by looking at the source. So before we jump to the demo, like I said, I did a talk last week in KubeCon comparing fluentbit and the collector. So I'm not going to go on the entire content. We don't have time, but I want to share a few aspects. So the first aspect is that in the design aspect, what is important with fluentbit 2.x, 3 has been released Friday. I'm going to try out next week. I will let you know about the details on the YouTube channel. But it's going to be better for traces, and it's for the metrics. It seems that they are providing features. But in fluentbit 2.x, in the traces side and the metric size, you were not able to process. In the fluentbit world, processing means parsing and filtering. You will not able to adjust the metrics. So you will basically, it's a gateway. So you send something in and it goes out directly to the backend, which was quite painful. So that's the first things. In the collector, it's not the case. So that's the first aspect. Is fluentbit 2.x is great for logs. For the other, we can discuss. But now let's have a look at the few results. I did many tests to build that presentations. And I did a ramp-up test. So the way I'm stressing those components, I'm doing a ramp-up test on 2 demo applications. And because they're receiving more traffic, then those apps produce more logs or more traces. So this is how I was doing those different tests. And here I'm looking at the ramp-up test, 2 hours, where every 30 minutes I'm adding 50 users on each applications. And you can see that, for example, the trace received it's basically aligned with the ramp-up of the stress applied on the applications. And if you look at the CPU usage, fluentbit at the beginning is about 400 millicores to 500 millicores, and the collector with the load starts to increase heavily, and is above the fluentbits. But more, what bring my attentions was the memory consumptions of the collector, because you can see here in about 2 hours I reached 1.5 gigs. And I asked myself, yeah, that sounds like a memory leak. So I did some tests and I figure out, so here's the results of a soak test, 24 hours. In 24 hours with only metrics, traces, and logs, constant load, so no ramp-up tests. What I saw here, fluentbit was super stable, consumed about 15 to 40 megs, while the collector consumed in a couple hours, 10 gigs, crashed and restart. So if you do the same load coming in and doing 24 hours and you see the memory increase, you say, that sounds like a memory leak. So I opened an issue on the GitHub repo of the collector, and it's related to Prometheus receivers. And I thought to myself, okay, how can we go and resolve that? And there's a feature specifically for people who run in Kubernetes called the OpenTelemetry operator. And that operator brings a new feature called a target allocator. So I don't know if you're aware of that, but that target allocator, when you deploy your OpenTelemetry collectors, you have a CRDs, and that will basically define how the collectors will be deployed. And you have an option to enable the collector, the target allocator. And what does it mean? Well, when you do that, it takes the scrap config of your pipelines, it will send it to the target allocator, and the discovery of the metrics, the relabeling configs and so on, are done not on the collector anymore, it's on a target allocator. And at the end, the target allocator says, okay, how many replica do I have of the collector? Oh, 3. Okay. So I'm going to take all the metrics that you have requested. I'm going to split it. So create different jobs. And he will split it equally. I mean, it depends. Sometimes you have metrics that are more heavier than the others, but at least the number of jobs are equal. And then he distributes it. So the collector at the end, he doesn't scrap. He sends an HTTP request to that target allocator. So, hey, give me the metrics, give me my jobs. And then the collector is doing less work. He just have to reach out to the endpoint and get the right things. And when I did the same test, and you will see that today I'm using the target allocator, so that's why I wanted to share this. When I enable target allocator, same test, 24 hours test, constant load during 24 hours. First of all, you can see here, instead of reaching 500 millicores, the maximum collector OTLD, so is consuming 200 millicores, but the others are about 100 millicores. So then at the CPU, at the end, it's good. And then instead of having 10 gigs consumed in 24 hours, here, one of the instances of my collector reached out 800 megs. Not 10 gigs, 800 megs. And then the target allocator, because you have an extra workload running, it consumes less than 10 millicore and then 60 megs. So at the end, if you sum up the resources required for all those collectors, so for metrics, and because I have a daemon set collector for the logs and the rest is a stateful set for metrics and traces, if you sum up all the resources required, I'm consuming less than if I were using one instance of the collector. So at the end, keep that in mind. Target allocator is a fantastic feature. I love it. And I would recommend, if you use the OpenTelemetry, if you use Kubernetes and OpenTelemetry collectors, use the OpenTelemetry operator to take advantage of that feature. And just to sum up this small summary, so here is the comparison, and at the end, fluentbit is super lightweight. So if you are edge devices and you want to have a really lightweight component, fluentbit will be better because it consumes 15 megs, not more. So it's very lightweight. All right, so now I talked so much. Let's jump to the demo. I will go fast because I want to cover other details. I like that content, so you can feel it because I'm passionate about it. I'm trying to share my energy, and I hope that you like it. All right, so let's go to the demo environment. So before we start to looking at files and stuff, I want to start with loading first. Dynatrace. I want to start with the service screens to show you what we have in this demo environment. In fact, let me show you the slides. So here, by the way, on the bottom, you can see it's a URL for the content for this performance clinic. I use intentionally Istio because Istio will produce Envoy metrics, and I really want to get those metrics with using the collector. I'm using the OpenTelemetry demo, the OpenTelemetry collector operator, and you can see here I have 2 instances of the collector. One is going to be stateful set for metrics and traces, and the other one is daemon set. Why? Because I want to collect logs. And for collecting logs on my cluster, I need a daemon set deployment. So that's why I have 2 instances of this. And then I have a couple of Prometheus exporters, because at the end, I want to show you about processing metrics and traces. All right, so if you jump back to this service screen. So if you look at the service screens, I have configured Istio to send OpenTelemetry. And as a result of that, you can see that I have I have one screen, one service, sorry, for each individual envoy, and then I can see that all the different communications. Or if I look at one of these this trace here, I will be able to see the diffuse trace with ingress, egress, or each components, the interactions, and that works fine. And Envoy is producing OTel logs and OTel metrics. So I expect, if I go to the Kubernetes application, like I discussed before, if I go to the deployments, any of the deployments, in fact, for example, I was looking at the checkout service, which is here. Let's open the details of that. And you can see here, I have the additional telemetry data. So if I click on it, you can see that I have my Envoy metrics. So then here we have the list of all the Envoy metrics attached to that workload, because here we're looking at the checkout service workload. And I have all the Istio and all those things. So you may ask yourself, okay, so great, this is awesome, like I said, but how do I do this? And same thing for the logs here. Here I'm running the OpenTelemetry collector to send my logs, and those logs end up to the right component. So the idea here is to show you how you do this. So let me open a collector pipeline. Here it is. Tick. And in this repo, I have different things, and I mainly use this one collector deploy, as Damien said, to collect all the logs, and I will use the file log receiver to read logs the from my cluster, and I will do some processing to get some metadata. And what is interesting, like I said, I'm using a couple of processors. I'm using the Kubernetes attribute processor, as you can see, where I have the pod associations defined with a pod name. And then I'm using transform. You can see here the transform in the case of in this example, it's a log using only the resources. And you can see here it's filling it the detour workload kind. And it says if the attributes stateful set exists, it's going to be stateful sets. Otherwise, it's going to be I'm filling in the Kubernetes the stateful set naming, the workload name. So all the things that we need to put the workload name and the workload kind. This is done with these sections of the transform processor. So not very complicated at the end, five lines, and it's going to be generic for all your workload. So it's exactly what we needed. And the other thing is, remember, I wanted to add the cluster name, and this is not exist. So here I'm using a attribute processor, the resource attribute processor, where I'm adding a new field into my metadata. So that's from the log perspective. In the metric side, it's going to be quite similar. You will see. But the difference is that here I have, of course, a more complicated Kubernetes attribute scrap configs from Prometheus. And then I am here. You can see that I'm using the filter to drop some metrics. And again, I'm using Kubernetes attribute processor. And again, somewhere in the bottom, so I'm doing this for each signal. So you can see transform. You have the metric statements, the trace statements, and the log statements. You need to do that because you need transform works like this. You need to select which signals is targeting by action. And last, I'm doing some few changes because I have some custom exporters that has different names. So I'm doing this to fill in the right naming. So again, this is very generic for most of your exporters. And then in the bottom, you can see that for the metrics, I'm receiving Prometheus and OpenTelemetry. I'm filtering to get out the histograms. I transform, and you can see here there's a cumulative delta where I'm converting. Before sending it to Dynatrace, I'm converting it back to Dynatrace. So that's typically what you need to get the metrics that you saw from the Envoy in the right screens. But then you have some challenge because you have exporters that are exposing metrics not related to himself, but from other components. And here as an example, because I'm using the target allocator, which is amazing, I don't have to use a scrap configs. It's able to detect automatically the resources, the CRDs, the custom resource definition files, from the Prometheus operator. So here, this is the service monitor. It's a way of attaching metrics to Prometheus. So I'm using this to deploys, which means you can have teams that deploy exporters, and they can define their labeling config directly. So you don't have to do that anymore. That's a good sign. And here you can see that I'm saying, okay, I want to drop a scrape because there's always a scrape metric. All the metrics starting with Go. The uptime, I don't need that. So I'm already filtering a bit, and then I'm getting some pod name from specific fields, and I do the same thing from QStat metrics where I am dropping things, and then I'm extracting the deployment name, the namespace, and so on. So you can see here, it's not in collector anymore. I can do that directly at the service monitor. So it's even smarter. So it means the team who wants to deploy an exporter, they can do it, and then you manage the collector. You can just do the right filtering to drop anything. And then you will ask yourself, yeah, but how can I make sure that I know the right rules? That were excellent questions, and this is why I'm going to resume with some few slides and jump to the rest of the demo in a few seconds. So that's why you need to observe the observer, and to do that, we are relying on the collector that will be transporting our logs, our metrics, our traces. And as you can understand, if this collector, as you saw in the soak test, it crashed. So I want to avoid that, because otherwise, if it crashed, I'm losing data. And we don't want to go in that direction because we have SLOs built in, we have alertings built in, we have so many things that we have built that if this is crashing, then we are completely blind. So what should we pay attention? Of course, I'm not going to describe the resources aspects from a Kubernetes workload. It's one of your core most important workload in your cluster. So treat it as a best citizen. So look at the resources, make sure it's ready, make sure the namespace is healthy, make sure the cluster is healthy, make sure that it's not over throttling. So this is, you've been used to that, so I'm not going to teach you anything about this. What I'm interesting is the last box here. I need to look at, do I have data dropped? Do I have any errors when I'm exporting the data to Dynatrace? Do we have any network issues? So, for example, a pod is not able to reach out to the collector instance. That's a sign of a problem. I need to check continuously on the health of the queue length of the collector. And it's a Go component. So there is a heap size and a garbage collector. So I'm going to check also this piece. And last, all the exceptions that are generating when you're sending data to Dynatrace from an OTLP protocol, if the collector will keep generating those exceptions, first of all, it's going to be consuming more memory. It's going to be more challenging for the collector. So try to look at those exceptions and removing them. So if there are metrics that are not supported, build the right filter rule, build the right transform rule, whatever. So then you're reducing those exceptions, this noise produced by the collector. So what is great is the collector has, by default, some metrics exposed. So there's a telemetry service. So here you can see that you have to enable it at the bottom of your service pipeline by defining which address the metrics will be exposed. And it's going to be at the end some Prometheus metrics, which means that I need to add in the Prometheus receiver a scrap config that will scrap the metrics produced by the collector. So that's why I will always have like a Prometheus receiver job that will be in charge of collecting my Prometheus metrics. And again, the rules that we described before, we don't support histogram, we don't support, it's going to be cumulative metrics. So we need to convert that into delta. We need to filter the histograms on the metrics produced by the collector. So that's the golden rule. Then what are the key metrics that we look at it? And specific for auto scaling. So in my case, I'm using the OpenTelemetry collector operator, sorry. So I don't need to scale. It's going to be managed. But if you manage your collector by yourself, then there are some signs of unhealthy behavior of the collector. So when your collector is sending data to Dynatrace, if there is I don't know, problems in the HTTP world, if there's an issue, networking, whatever, or there's a problem with the metrics, then the data will be kept in memory and he will try to do a retry. And when it's kept in memory, it's stored in a queue size. So the exporter has a queue, and basically he had the size will be the current size used by the queue, and then there's a maximum capacity. So keep track if the size, how the size of the exporter behaves versus the total capacity. It's really important because at the end, if you see that you're starting to grow to 5%, wow, it sounds like there's a problem. So this is going to be a really important aspects to look at. The other thing that I'm going to show you with dashboards is look at the Kubernetes service mishap lookup. So I'm going to show you the metrics that is important. But the other aspect is detecting memory issues. So when your standards of the market is use memory limiter, it's a way of controlling the memory utilized by the collector. So if the memory exceed in a certain situation, if you have a memory pressure on the collector, I mean the memory limiter processor, which is always the first processor, by the way, in pipelines. So if it's under pressure, the memory limiter would do, okay, so I'm refusing the records. And refusing means that it will send the metrics back to the receivers because it's supposed to be the first processors. And so then you will have some counters that will be populated. So if you have receiver refuse spans, receiver refuse metric points, or receiver refuse logs, it means, yeah, there is clearly a memory pressure somewhere. So I need to figure out what happens. And then also what I'm doing as well, I'm always comparing how much data I've sent into the collector and how much data has been exported by the collector. So if I do some filtering, I may see some 10% difference. But if you see that, for example, I have like a 50, 60% difference, then this is clearly a problem. So this is what you should pay attention. So let me show you in Dynatrace what does that mean. So I have first, let me start with the dashboard. So this dashboard that I've built is available on the GitHub repo I shared before. So here I'm doing this graph here where I am building a ratio. So I'm getting the queue size versus the capacity, and I'm comparing it. So here it says 0%, but if I start going up to 3%, oh, I need to do act. I need to act because I know that is a problem, and that could be basically I can use HPA rules with external metrics with the help of Captain to scale my collector in that case. Here is there's another great metric exposed by the collector called the hotel SVC. So the uh, hotel open telemetry collector service, Kubernetes IP lookup missed. It means that someone has tried to send data to the collector, but the DNS lookup missed, which means there is no pod responding. So if you have this number growing, clearly it's a sign there's something wrong. I am also counting the number of collectors. In my case, I have a cluster with 2 nodes. So I have 2 daemon sets collector and 2 stateful sets. So that's why I have 4. And then I'm doing like a pie charts with you can see 50% of daemon sets, 50% of stateful sets. And then here I'm looking at the number of metrics dropped. So you can see I only have logs and metrics. Logs is almost nothing, and the metrics is quite high, and that's why I'm adding here. I'll show you with a notebook what that means. So here I have the metric name, the type, and then the code responded. So then, for example, I can see that I'm sending tons of type summary. So it means I'm going to do a lively with you guys. I'm going to filter that. I mean, let's drop the summary because it's just polluting my collector, and that is potentially could make my collector unhealthy. Then I'm looking at the receivers, how much data comes in, the metrics, logs, and spans. Do same thing for the refused. So refused, if I see that I have some things refused, again, keep in mind that's a memory limiter approach. So I will look at it. No, that's sorry, mom. Logs refused in terms of receiver, but then this is the processor sections where I'm doing the same thing, looking at the number of data accepted, and here I'm looking at the signal dropped by memory emitter. So if I see something dropped, then I definitely need to scale up. And last, I have same thing for the exporters, and then I'm looking at the collector process with the heap size, the number of bits allocated. So the heap size will be a way of pay attention to heavy garbage collectors. And then, of course, I'm using the traditional Kubernetes metrics for the metrics, the CPU, the memory, and then I'm doing like a ratio, what I'm in and what is out, to figure out that always 100%, or if I have less, then I can be worried about things. And then because I'm using the target allocator at the end, I have the target allocator vision. So I talked about the logs, and you can see here I'm taking the logs of the collector. I'm doing some parsing, and I'm basically the thing that you saw here. I can see exactly which metrics is causing problems, and then I can react. I can even imagine a workflow that will help me to clean up those metrics that is just making a lot of noise. So how do you do this? So remember, so I saw that I have some type summary coming in. So I will go back to the filter, which is here, and you can see only filtering the histograms, and summary is not supported. So then to reduce that number, I will just type here up, and I will do summary. Oh, sorry. Up, up. So here it is. I have it, which means now if I go to my cluster, so you won't see some differences because we don't have much time, but I can still do deploy my this collector. Okay, in a few seconds it will be. And then I will try to remove my intention here with this example is to, I know that I have some metrics drop because it's unsupported metrics. So I'm trying to remove, you can see that I have a lot of noise here. So by doing some few rules, same thing here, I have metrics that are not respected the OpenTelemetry standards. So I could remove those metrics that are just making some noise. So that's about the things I wanted to share in terms of demo. As a takeaway, I would say, make sure your code is agnostic. If you start using OpenTelemetry, having the collector, if you do things going through a collector, it's just that you don't have any agents in your code. It makes more sense. And then enabling observability on all the layers of your environment will be very efficient. If you do ingest data from external components, make sure to add enriched data. Make sure to utilize the OpenTelemetry distro of Dynatrace because it's going to be secured, it's going to be supported, and you will have, at least you have less issues or challenge with using the OpenTelemetry contrib version because at the end, like I said, there is no security checks. And then look at the metrics from the collector, the health of your pipelines. Try to keep track on metrics that could be rejected because it could happen, and adjust your pipeline over time. I think that's going to be my takeaways for today. And there's plenty of content coming out on my YouTube channel, like I said. So check it out; it's out there. And there is one coming out this Thursday, comparing fluentbit in details with the collector. So check it out; it's out there. All right, so I have a few minutes for the questions, and I have a few questions, which is great. So thanks for asking questions. And so I have one question from Peter. So if I understand correctly, OTTL is a bit like a grok filter in Logstash. Yeah, it's a good point, Peter. It's a bit similar, but it's not about filter. You can do, like I said, you can parse, you can convert, you can do tons of things, and it's a statement, so it runs one statement of the other. So if you do some change on the first one, the second one, of course, will be affected. So and then there's notion of cache and so on. But if you want to learn more about the OTTL, I have a link of a dedicated episode, which is up. If I go back, it's this one. How to collect logs with OpenTelemetry, and I'm doing like a deep dive on OTTL. So check it out. It's out there. Corey Smith, my org use Prometheus extensions to collect data today. What exactly are you saying isn't accepted? So the Prometheus extensions in a bare metal environment, it's a Dynatrace extensions that grab the metrics for you. And then because we don't support histograms, it will drop them or it will convert things on your fly. So you're not even aware of that. If you use, for example, for those who's been using the Kubernetes, the Prometheus support from the operator, where you can put annotations in your workload, same thing. It's the active gates who reach out, pull out the metrics from the exporters, and do the right conversion. So you don't have to worry about anything about it. But if you start to do this metrics extractions using the collector, you end up with metrics in a Prometheus format. So you have to convert. And also you will have probably histograms. So there is nothing that avoid you to sending it direct to Dynatrace. So if you want to avoid having metrics rejected, then this is where you're going to filter a summary metric like I did a few minutes ago, or histograms, for example. So that's my take. But again, the OpenTelemetry the Dynatrace operator can collect those data for you. But sometimes if you want to filter, you want to massage, because at the end, if you do that with the operator, there's no way of reducing the labels as you saw. So you will grab the entire labels. There's no way adjusting the size of the labels, this cardinality problems that I mentioned. So having the collector, this is the best tool to do that. If you know that you have expensive metrics, going through the collector, you will be able to change it on the fly, and then controlling the actual cost of that metrics when he ends up into Dynatrace. Again, it's just for tips again. I'm not saying that all the metrics are expensive, but sometimes if someone produce, let's say, a metric that has 100 dimensions, if you're sending to Prometheus, it will probably die. We will not die. We will store it. But again, the storage of a metric with 100 dimensions is like the cost is exponential 100. So so it's like 100 times, every time series is 100 times. So it's going to be super, super expensive. So that's why maybe in the consumptions of your license, you will have an impact. So if you know that you're dealing with those type of metrics, the collector will help you to massage, drop, control, and do things like this. All right. Is there any? So I think I answered to those questions. Yeah, if you have any questions, feel free. So, and otherwise, we are almost top of the hour. So I would like to thank you everyone to be here connected for this hour. I hope that the content was useful, interesting for you. I mean, again, the distro collector of Dynatrace is out there. You can do tons of things, enrich the community's screen with it. So feel free to use it. It's going to be super useful for everyone. If you have any questions about collector, open telemetry, or anything, just reach out to me. I would be very happy to help you out or to get you started or give you my insights for sure. All right. So if there is any other questions, I suggest to close these sessions for today and have a great end of the day. And if you enjoyed that content, don't forget to like and subscribe to the Dynatrace YouTube channel. See you.